In this lesson, we're going to take a look at valence electrons. Now, valence electrons are the electrons on the outside of an atom. And it turns out those electrons are really important because they're the ones that are available to do things. They're the ones that can form bonds and attract other particles, and they're going to determine how reactive, chemically reactive, an element is. So we're very interested in valence electrons. Now, like I said, these are the ones in the outermost occupied energy level. And they determine the properties of the atom. By properties, I mean chemical reactivity, what kinds of things these atoms will do. They do follow the octet rule, which means if they have 8 valence electrons, they don't do a whole lot. If they have less than 8 valence electrons, they will form bonds in order to get to 8. So 8 is the magic number, and it's stable. And that gets back to the atom, because we know it's got the nucleus, and it's got the first energy level, which holds 2, and the next energy level, which holds 8, and the next energy levels hold more, but 8 is his stable number. And so I said 8 or 0. So imagine I had an atom that had 2, 8, and then 3 valence electrons. How could it get stable? Well, it could add more electrons to this energy level, or it could take electrons out. And if it takes out all 3, well, this energy level isn't occupied anymore, and it drops down to having 8, which is stable. So putting 0 here is the same thing as dropping down to a full energy level. Now, I did say 2 for small atoms, and that's because small atoms only have to fill that first energy level. So essentially, it's the full energy level rule. If we have our outer energy level full, then atoms are stable, they're happy. Electron dot diagrams allow us to ignore all the junk that's going on the inside and just look at the valence electrons, which is going to be very helpful in figuring out what kinds of bonds and how these atoms will bond. So we use a symbol, the element symbol, to represent all the internal particles, and then we put electron dots around the outside to represent the valence electrons. So we know from before that if we want to draw a model of an atom, we look up helium, we say, okay, helium has 2 protons, it's element number 2, and then it's got well, 4 minus 2 is 2, so the neutrons are 2, and then 2 protons means 2 electrons, and so we'd go protons, 2 plus, neutrons, 2, and then 2 electrons here and here. But now we can replace that by writing helium, and because it's got 2 electrons, 2 valence electrons, we're going to write helium with 2 valence electrons. Now, helium breaks a rule. Usually on electron dot diagrams, there's 2 rules. No side gets 2 dots until all sides have at least 1, and only 2 dots per side. Okay, so if you think of the element symbol as being in a box, we can put a dot here, or here, or here, or here, and once we've got dots everywhere, then we can put a dot here, or here, or here, or here, so 2 dots per side. Helium gets to break that rule because it's got 2 valence electrons, and they fill that energy level up. So if the energy level is full, we want it to be on the same side. Argon is another example. Argon 36, well, argon is element number 18, so it's got 18 protons. It's got 36 minus 18 is 18 neutrons, and because it's got 18 protons, it's also got 18 electrons. And so we would go protons 18, neutrons 18, and then we'd put 2 electrons, and then we draw 8 electrons, and then we draw 8 electrons. It takes forever to draw those electrons. So now we can just do argon, and we can put a dot, 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 dot. And we can look at that thing and go, oh, look, argon's got 8 valence electrons. Good to go. One more, and then we'll get a few notes on electrons and their trends. So this is fluorine 19. If you go find the periodic table, fluorine is element number 9, which means it's got 9 protons. 19 minus 9 means 10 neutrons. And of course, it's got 9 electrons because protons and electrons balance. So we put protons 9, we'd put neutrons 10, we'd put 1, 2 electrons, and then we'd go 7 electrons out here. Well, that means on our electron dot diagram, we can just go 7. 1, 2, 3, 4, 5, 6, 7. Now, you'll notice I broke the rule and I didn't put 1 per side, but that's because I knew it was 7, and so I knew I was going to have 1 unpaired electron, the rest would be paired. Now, there are some trends in valence electrons, and this is because of the way we arrange the periodic table. We put the periodic table in rows and columns. The columns are called groups or families, and the rows are called periods. Now, periodic things repeat, and it turns out Periods are called periods because they repeat. On the left side, there's always a metal. On the right side, there's always a non-metal. And the number of valence electrons increases from 1 to 8 as we move across. So column numbers on the periodic table give us the number of electrons. This is good information. Know this. Column number gives the number of valence electrons. This is true for the A group. The B group, the ones in the middle, yeah, those are a little bit different. But the A group, this is true for. So the number of valence electrons increases from 1 to 8 as you move across the periodic table. Row 1 disobeys this rule. Row 1 goes from 1 to 2. It's only got 2 elements in it, hydrogen and helium. Then it starts over, right? But the next energy level holds 8. So we go from 1 to 8. Atoms in the same column have similar properties because they have the same number of valence electrons. Like I said, valence electrons determine chemical reactivity. If it's the same, they're going to behave similarly. Atoms in the same row have changing properties because their number of valence electrons is different from one atom to the next, and so they're going to behave differently. Now the last thing is to draw valence electron diagrams for calcium and bromine. It used to be, to get this, we'd have to go to the periodic table and find the protons and then fill in our energy levels and see how many valence electrons they have. But now I can just go to the periodic table and look at calcium. Calcium is right here in 2A, which means its electron dot diagram has 2 dots. So calcium is Ca1, 2. Bromine, I know, is in column 7, so I'm going to go 1, 2, 3, 4, 5, 6, 7, and we're done. So when I know the number of valence electrons from the column numbers, it's a heck of a lot easier to get the electron dot diagram.